Assalamualaikum and hello. We got the last method in determining the empirical formula from combustion data. So we have combustion of hydrocarbons. Usually we put it as CXHY. The combustion should be in excess oxygen so that it will form carbon dioxide and water as your product. I want to emphasize here that hydrocarbons is an organic compound which consists only carbon and hydrogen atoms only. So when you put in your molar table, only these two elements for hydrocarbons. Next one, we have combustion of organic compound. Usually for organic compound, it can be CHO or CHN. It depends on the question. Of course, we are going to use excess oxygen to produce carbon dioxide and water as well. And this is organic compound that normally consists of carbon, hydrogen, and oxygen or nitrogen. So the difference only for the last one, the last element, whether it is oxygen or nitrogen. So let's try one example. Here I got example 9. 1.0 gram sample of compound A was burned in excess oxygen to produce carbon dioxide and water. So this is a type of combustion data question. When you want to find out the empirical formula based on the mass given of carbon dioxide and water. So the solution for this one, you have to use mole concept. In mole concept, you got 1 mole of carbon dioxide, so there will be 1 mole of carbon. 1 mole of H2O, there will be 2 moles of hydrogen atom. You can see here, this one, from its formula. So this is what we are going to use in the next calculation. So let's go to part 1. You have to determine the mass of carbon. So I'm going to put the first sentence, 1 mole of CO2, there will be 1 mole of carbon atom. Which means when you comparing with the mass, you got the general mass of CO2 which will be 44.0 gram. So it must be 12.0 gram of carbon atom. So this is for 1 mole. However, in this question, the mass given for carbon dioxide is 2.52 gram of carbon dioxide. So you have to find out X value for mass of carbon atom. So try to do the cross multiply between carbon dioxide and carbon atom. Therefore, you will have mass of carbon atom equals to 0.6873 gram. Don't forget to put the mass of element that you got in 4 decimal places with units, just like this one. So settle for first element, carbon. Now we go to the second element, which will be our hydrogen. So this is the general. In 1 mole of H2O, there is 2 mole of H atom. So which means that in terms of mass, I have 18 gram of H2O. There will be 2.0 gram of H atom. Why 2 here? Because you got 2 mole. So please be careful here. Now, in order to get the mass of H atom, you are comparing based on H2O. So, based on the question, you got the mass of H2O which will be 0.443 gram. So, you want to find out the mass of 1 hydrogen atom in this case. So, do the cross multiplication. You will have this value for the mass of hydrogen, which is 0.0492 gram. So settle for the mass of hydrogen. Now we go to part 3. Don't forget, we got one more element, which is oxygen. So how you want to find out? You are going to minus all the masses of all elements. So you need to find out the mass of oxygen. You have the mass of sample minus the mass of all elements that you've got so far, which are carbon and hydrogen. So you got the mass of sample 1.00 gram minus with the values that you got, you will have the mass of oxygen 0.2635 gram. So this is how you calculate based on combustion data. Now, don't forget, in order to determine the empirical formula, we have to construct the molar table. So, your molar table should be with carbon, hydrogen, and oxygen as your elements. Continuing with moles, don't forget the units, mole, and the simplest ratio as your row. So we are going to put all those values that we got for the mass and calculate the number of moles for each of them. So you got for carbon, you got for hydrogen, and you got for oxygen. Please be careful here. We are calculating the moles for one hydrogen. So that's why the molar mass is 1.00. You got the smallest value for moles, which is 0.0164. So I'm going to choose that as my denominator to determine the simplest ratio. So I will have for carbon here, for hydrogen here, and for oxygen. Please be careful for this one. It's quite far to round off. Now you have to show what you've understood from the previous video about multiplying a factor number. So for this case, I'm going to choose multiply by 2. So all of them should be multiplied by 2, not only for carbon. So you will have this one as 7, this one as 6, and this one as 2. Final one, you can determine the empirical formula for this case, which will be C7H6O2. So this is how you calculate and determine the empirical formula based on combustion data. It's quite different because you need to determine the mass of carbon based on CO2, mass of hydrogen based on water, H2O, and last one, mass of oxygen based on mass of sample. After that, you can start constructing your molar table. Try these 3 so that you can practice your understanding for this video. That's it from me. Thank you.